Hello, good day. This podcast will outline the simulation and modeling of antenna designs for the IEEE 802.11 standard for Wi-Fi and Bluetooth. The purpose of this project was to investigate the effect of cross-sectional area on the antenna performance parameters of a planar inverted F PCB antenna. Specifically, the radiation pattern and directionality of two antenna designs were analyzed to determine whether 3D printing capabilities can improve the performance of antennas for Wi-Fi and Bluetooth networks. The models were created based on the reference line entitled AN697 from Silicon Labs for PIFA antennas operating in a 2.4 GHz frequency band. The signal applied to the antenna is input at this point, shown here, and the antenna connects to the ground by two vias or shorting pins, shown here. The two antennas were modeled using the RF module in COMSOL. The first model was created using cylindrical primitives, so the cross-sectional area of the copper trace took on a more curved shape, while the second model was created using block rectangular shape primitives. The two antennas were modeled on a 0.8 mm dual-layer FR4 board. Here, the cylindrical model is shown, followed by the rectangular 3D model. A boundary condition was created at the far field around 8 inches, which is just around 2 times the radiating wavelength. The physics of each model was defined and configured in exactly the same manner, so that the differences in the computed results would stem from only variations in the cross-sectional area of the antennas. The 2D polar plot computed for the two models are shown here. The cylindrical plot is shown on the left and the rectangular plot on the right. The cylindrical plot does in fact show a less omnidirectional pattern. However, the magnitude of the electrical field strength is much greater in the cylindrical plot than the rectangular model. This may be so since the source of the emitting radiation is curved. It is more likely to be incident on the spherical, perfectly matched layer far field boundary at 90 degrees, and therefore more radiation will be absorbed and less will be reflected. These next images show the 3D radiation patterns for the two antennas, which is just a 3-dimensional version of the polar plot. An interesting phenomenon is to note that both antennas appear to radiate fields the strongest vertically. This may have been due to imperfections in the geometry of the model, or because the copper trace is closest to the edge of the board at the edge of the antenna. In conclusion, the cross-sectional area does have an impact on the electric field produced by the antenna. Specifically, the magnitude of the electrical field appears to be greater when a cylindrical cross-sectional area was used. It may therefore be possible that 3D printing can improve the antenna gain, but not necessarily the radiation pattern. This concludes our podcast for ECNG 3022 project. Thank you for watching.